This is for designers, product engineers, and innovators that need to make CNC machined parts to bring their inspirations to life. If you're using Fusion 360 and would like to use a CNC machine to make a part, welcome to SendItCNC. You're in the right place. Today we're going to do an elevated version of the CNC aluminum box that we were working on in previous videos. This version will illustrate machining more organic contoured surfaces and making threaded holes. We'll add CAM, then get it made at SendItCNC.com. Welcome to SendItCNC tutorial number 4. As you know, we're doing something kind of radical and new here and enabling designers to submit their own CAM programs for execution on our CNC machines in the cloud. The model we're working with today is called BoxPlus. It's similar to EasyBox, but a bit more sophisticated. The box is going to have a lid, and the lid is going to be screwed on with beautiful little size 632 stainless steel socket head cap screws. We'll drill and thread the holes for those screws. Let's take the box top out of visibility and the Allen head screws as well. You can see this box is a little more rounded with radiused edges instead of flat chamfers. We're going to use 3D surfacing for those rounded surfaces, and this will provide an example of how to CAM that quickly and easily. Let's get started. We're going to go really quickly over operations that are similar to ones we did in past videos and concentrate here on the new contouring and thread tapping operations. First, we'll create a CAM setup so that we can machine our part. On the Utilities toolbar, click on the SendItCNC add-in, and the Manage Setup command window will appear. All that's required is to select the model, the box in this case, and click Create Setup. Once the setup is created, in the Fixture/Op field, pick Fixture for Second Operation. Now we're looking at the setup for the second operation. Click the Operation is Used checkbox. Let's put this on the second step of the vice jaw to hold it more securely. Open the Customize Fixture group and select Middle Step from the Jaw Step dropdown. Now we'll save this as BoxPlus First and Second Ops. Now we're ready to go over to the Manufacture workspace. We'll use the provided CAM operations for probing, adaptive clearing, and facing as we've done previously, so click Generate to compile them. Now let's change Visibility Sync and take the work holding vise out of view. Next, let's finish the outside of the box. So, 2D contour with our go-to tool, number 91. Remembering the radius of the cutter, and so extending 50 thou, not below the selected contour, but 50 thou below the bottom of the model. So far, the CAM operations have been pretty similar to those we used on the previous EasyBox project, but you can see the rounded version of the edges and inside of the box. So, first let's round off the top edges of the box. When the box is finished, these round fillets will look more appealing and a little less angly than the chamfers we put on the previous version of this box. So, we'll do a 3D contour operation. We're going to use tool number 93 with a large radius. Large radius end mills are generally great for contouring things. Some folks favor ball end mills, but here's something to consider. The cutter surface speed near the very tip of a ball end mill gets very low, and it's effectively zero at the actual tip, which has implications for how you can use the ball end mill and get reliable surface finishes. In previous videos, we used tool number 93 in places where its large radius was an exact match for an inside corner radius that we were machining. But that is not the case here. In fact, the inside corner radius of this box is much larger than the corner radius of the tool. The tool path looks really odd, and that's because we didn't set the step down appropriately. The default was a step down which would be appropriate to adaptive clearing. For a finishing operation like this, we want to do a much smaller step down, say 5/1000ths of an inch. You might want to go even smaller than that depending on how great a finish you want to achieve and how much machine time you're willing to use. The 3D contour operation wants to finish the whole outside of the part, but we actually don't want it doing that. We just want to finish the top fillets. So, how do we restrain the scope of the contour op? There are a few options. For example, we could try restricting the toolpath to a range of slopes or a range of heights. Here's an approach that works really well in this case. We're going to say there is an outside boundary and there is an inside boundary, and keep the tool center inside those boundaries, except that the boundary should be interpreted in terms of the contact point of the tool, not simply the center of the tool. If we do that, we get a pretty beautiful tool path. How about the inside of the box? I'll just duplicate our contour toolpath because that's easy, and I'll remove the boundary constraint. This time, we'll specify just the surfaces that we want finished. We'll select Touch under Avoid Touch, and then select the 8 segments of the surface. Click and hold to see a pop-up of the surfaces under the pointer. We're still going to go with a 5 thou step down, remembering that 3D contour takes a constant step down between each pass. You can see where the walls are steep. It looks like the result is going to be pretty good. By the way, this has the effect of finishing the inside vertical walls as well. Then, as things get shallower and shallower, 3D contour is less and less our friend when it comes to finish quality. It becomes less and less effective compared to how well it worked on the steeper walls. So, you would expect visible jaggies on the actual part in the shallow areas. So, we'll only apply this contour toolpath from 30 to 90 degrees, where it's likely to look its best. We could do from 0 to 30 degrees with a different contour toolpath with a smaller step down, or perhaps even better, we could use a 3D scallop toolpath, which has a constant step over instead of a constant step down. So, let's create a derived operation. We'll scallop from 0 to 33 degrees with a 5 thou step over. That should look pretty nice. We have a 3-degree overlap to ensure a nice transition between the surfaces cut by the two toolpaths. You can see that from 30 to 90 degrees, the 3D contour took just under 3 minutes, and then to do the rest of it with scallop at a constant step over is a little under 2 minutes. This kind of surface contouring takes longer than just cutting a chamfer. Simulation even takes a little longer to crunch through as well. It looks like we need to apply 3D horizontal in here to get the interior floor of this part to look beautiful. For the horizontal toolpath, we'll use our 1/2 inch corner radius end mill, tool number 91, and we'll fence it in with a boundary since we only want it to finish the bottom of the box. Things are looking great. Now it's time to drill and tap those holes, and here's the easy way to do that. We'll select Create from Template, and then select Template. The template we're going to select is from the Spot Drill Tap Chamfer set. It will be the template for a 632 thread. The template brings in 5 operations. First, spot drilling to mark the exact spot where the hole will be so that the tip of the drill doesn't wander around. Then drilling the hole. The correct size drill is pre-selected. Then chamfering the hole. Next, tapping the hole with a forming tap. And next, there's a post-tapping chamfer, which makes things look pretty. Let's start with the spot drilling operation. We just have to identify the hole faces. Fusion's hole drilling operation is pretty smart. We just select same diameter, and Fusion finds all the holes. Easy. Next, the drilling operation. Pretty similar to the spotting operation, just select same diameter. Next, select the 4 contours for the holes in the chamfer operation. Now we want to tap those holes, and again, it's the same situation as with the spotting and drilling operations, where we say select same diameter. And finally, select the 4 contours for the second chamfer operation. This final chamfer operation just makes the result more beautiful, since the tapping can distort the original chamfer. Okay, we've finished camming the first operation. So let's simulate. If you don't change any of the parameters on the spot drill tap template, and your threaded hole was created in your design as a threaded hole using the hole command in Fusion, then it will generally run without any diagnostics issued or corrections issued from SendItCNC validation. You can probably guess what we have to do here in the second operation, and it's pretty easy. We'll delete the adaptive clearing operation since we don't need it. We'll use the provided CAM operations for probing and facing as we've done previously, so click Generate to compile them. To contour the edges, let's just duplicate the contour op from the previous step. Then move the duplicate down here where we want it and edit it to select the appropriate machining boundaries. Simulate the second setup. Great, no collisions. Then both together. Perfect. We're disregarding the phantom collisions in the combined simulation. Let's hit Submit. In this case, we see the extra optional tools we used for the threaded holes, the 632 forming tap and the 1/8 inch drill, which are a package deal. We submit the job to SendItCNC, and here's what we receive in our hands as soon as the very next day. Magically fast prototype turnaround. We're going to machine the lid for this box in the next video, complete with engraving. CNC machining for everyone. SendItCNC is the democratization of manufacturing. Check out our other videos.